Hi, so how are you? Welcome to the first live interaction session for Learning Analytics Tools course. Before we jump into the Q&A, we create a set of additional reading materials or additional materials which clarify some of the content we taught in week 1 to week 4. Before we do that, firstly, thank you all for registering for this course. I hope you are learning and you are having great time in learning about learning analytics. This is week 3. You will be learning about what data to collect and how to use this data for preprocessing, how to apply this data for descriptive analytics. Going forward, we'll see a lot of tools. I request everyone to, when we talk about tools, look at the data from Kaggle or some other website. Try your own tools. Like if it is orange, try the tools. If it is process mining, try the tool. So that would, if you actually engage in the course, it will really help you to learn fast. So let me share the screen first. Excuse me. Just a minute. I want to move this. Okay. No, to select so your slide. No, I want to move this above bar. Click OK. So when I go for sharing, I use this one. Share then is going to slide. Yes. So I will quickly go through. The idea is that we've gone through the learning material from week 1 to week 4. We found that some of the content or needs some bit explanation, and we keep adding the content. For example, we added content about pre-processing. So we're trying to connect what are the missing points and how this the data pre-processing is important for the learning analytics, all those things. So this course material and learning content is developed by one of our TA, Jyoti.
Yeah.
So Jyoti.
Hi, everyone.
Yeah. So I think what we did, we gone through the slides for first 4 weeks, and we looked at the content where we're missing the links. We explained that in another few slides. Then we'll go through the questions. We got it from the discussion forum, also from the Google form we shared. Then we'll take any questions from the live audience. So in a week 2, the lecture 9, I think you would have done last week about the data pre-processing. And in abstract level, why we need to data pre-processing? Because pre-processing is very important so that if there are any missing data in the system, in the data we collected, can be handled. Why we need to address the missing data? To address missing data is important for the ML systems to perform well. If a lot of data is being missed and we're not able to identify, if you're not able to identify the reason or the data is missed, or one particular column is missed, and we are kind of predicting it based on the existing value, that may be also biased towards existing value. So we might be missing the key information. So the data missing can happen due to 2 different things. One is the human error or the system error. System sometimes, due to a minute change or all the reading or measurement tool has some whole malfunction, it might have the system error. That kind of been eliminated recently. The systems are evolving so good and they're getting very accurate. The system errors is not much in nowadays, but whereas the human error is still possible. Human error happens when the human collected a data about participants from the survey, or we collect data by question, by conducting a performance questions or test. Then we manually update that data in the Excel sheet or some database where you might make a human error. If you talk about the data collected by system, clickstream data, for example, we saw in last week, the clickstream data like the user ID, actions, those kind of as a kind of nil. Now it's not nowadays. It's not actually. There's no error in those kind of data. So what happens if we have a data error missing in the human error? It can be because they slipped, they forgot to enter the data, they would have wrongly entered the data. For example, they would have missed to enter the data of the particular mark or some particular the score. They would have wrongly entered the data of age is equal to 1. It's not possible. There would be some violations in the student ID, be by like 5003, but they entered double column. So the human error can happen due to slip, mistakes, or some violations. For example, the mark should be out of 50, but it is 450. Or the age should be, 1 is not possible. So that's just a mistake. So these are the missing data. If the data is missed, what we can do, we have to adjust them so that we can do pre-processing. That was the idea of why we need to pre-processing. This we want to add example in the slides. The another example we talked in the week 2 is that normalization and entity identity problem, but we did quickly so that we didn't have any examples. Why normalization is important? For example, for some of the ML models, not everything. Some of the ML models need normalization for to perform well. For example, in this table, you can see age comes from the range of 14 to 15. If you are conducting study in the class 9, or the age can be range from 18 to 21 or in a undergraduate or something like that. And we know the math score in terms of out of 1, it can be like 0.85 or 80, something like that. And this was 85, 88, they kind of given in a percentage. The English score is given in the absolute value, like 89, 84. So each data set we collected has a different scale. Age would be range from 14 to 15 or 15 to 18, whereas math score is different and English score would be different. And whereas if you collect the more of the data, there might be different scale range. To make this all the scales uniform, we can do the normalization. The normalization will come for, I can do the simple normalization like -1 to 1. There's some formula we described, or you can check the formula. And then all these features, that's age, math score, English score, will be in the range of -1 to 1. So the machine learning models can able to predict well if they apply the proper kernel. That is the idea. The another thing is we have to do data integration. For example, we might have a data collected in a multiple tables. You might have one Excel sheet about students' age, math score. Might be you might have had a maintaining another Excel sheet. I would have got Excel sheet from a system which gives you the student ID and attendance. Now you want to merge it. So the best way is that you can use this unique identifier that is a student ID in the both, and you can integrate the data. So this is very common thing in a database. But if you're not aware of the database, what we do, we combine this data based on the unique identifier. This key is a unique key which appears uniquely. And if you match 5001 and 5000, so data set S001 is the student ID, sorry. And you map the another column saying that attendance. So that's the idea. So we wanted to give an example in this slide, which is kind of missed in the previous, last week lecture. And why we need to handle missing data, why we need to have this, the standardization or normalization. Many ML algorithms fail. Okay, but some algorithms like K-nearest or naive-based algorithms support a missing data, but some algorithms fail. So you might be building a machine learning model, which will lead to correct result, incorrect result to missing values. So we need to be careful on what data we're giving. The data we're giving is provided is correct. So the missing data can lead to lack in precision, so that you might feel the model is not predicting correctly. It's not due to the model, it might be due to the data we fed into systems. So to handle the missing data, I think we explained in last week, if we can delete the data, you can impute, you can add, or can change the data. Input means assign value by something by references. The input means adding a value, assigning the value, or you can skip the data. When to skip the data, I think this slide is clear in the week 2 slides. I think it has been discussed. There are the type of data, missingness. It can be ignorable and non-ignorable. In ignorable data, there are data like missing completely at random or missing at random. So when you mean missing completely at random, it's like at random, which is missing the data and which we don't know the reason and everything. We can simply ignore or delete the data. Okay. Again, missing at the datum is like Missing completely at a random happens sometime, not many data is missing, a few data is missing. If the data is missing at random, but one particular column or one particular thing, you could either delete that row or you could impute the data. That's the idea. And if there are some data which are not at random missing, but it is missing as a pattern, we can see the data is kind of missing or some due to the failure in the recording data, system entering data, the programming, some data kind of missed it. In that case, we need to find out why the data is missing, improve the data collection method. You cannot impute or delete it. So we'll just show the example. That's the idea. For example, in this, it's missing completely at random. For example, there's a birthplace and the physics marks. There's no relationship between this birthplace and the mark. So it's completely at random. So we know this, there's no relationship. We just simply delete this row. That is possible. It's missing at random. Here, there's some relationship. For example, the female would have chosen not to enter the, date of birth. Right? Is that correct?
Yeah.
So in that sense, you cannot simply delete it. You should find out a way to impute the data. You can contact the participant and get the data. If not, again, you have to take a decision whether delete it or impute it. So it's all ignorable data if it is missing. But here, if you see, the student ID and income sources in 1, 2, 3 is kind of missing at not at the random, at some pattern. It might be due to when you write a script or you're updating, you might have got data from multiple Excel sheets. You're writing a script to update the data. You might have missed some values or incrementing values in the for loop or something like that. So this kind of data missing is important to identify. Then you need to go and check why is the reason. You cannot simply ignore this kind of data. You cannot impute or delete it. Instead, you have to make sure the data is kind of collected correctly. This is the idea of missing, not at a random. So you would see the pattern, this whole set of data is missing. You need to find why the data is missing. Make sure you collect the data and input data before we submit to the ML models. Okay, the week 3, I think you'll be watching a week 3 lecture. In this, I think we talked about Kappa score a lot. And we say that Kappa equal to 0 by chance, like it's a baseline. For example, if there are 100 students taking a course, 70 students pass the exam, 30 students fail the exam. If I predict if I want to predict the ML algorithm, my ML algorithm says that all the students in my course will pass the exam. My accuracy will be 70% because 70 students will pass the exam. So what really happens is I was able to predict the 70 students who passed the exam correctly. When I say all students, I was not able to predict any students who were failing. I got 0 in the, for predicting failing. But my accuracy, when I talk about accuracy of the classifier, I would say that my accuracy is 70%. That's very good accuracy. Somebody looks at, so you're able to do well in 70%. If the data is kind of imbalanced, for example, I want to predict how many students would score more than 90 marks in, out of 600 students or out of 100 students. There'll be like maybe 7, 8 students. So I would say 90 students will not pass, will not get more than 90 marks. If I say all the students will not get more than 92 marks, still my accuracy is 92%. I was able to predict the 92 students who are not able to get more than 90 marks correctly, which means when the data is imbalanced, which is the classes are kind of not balanced, the Kappa score, the Kappa value is important. Kappa 0 means we are just predicted by chance. Okay. So is there a possibility of negative Kappa? Yes, it is possible. I think that's the point we did not discuss. And negative Kappa means there's absolutely no relationship between the predicted value and the actual value. It is, in fact, it's opposite. Whenever I say pass, the student fail. Whenever I say fail, the student pass. So which means the classifiers perform really bad, or when the two raters, suppose consider me and Jyoti are rating some students or undertake some students, we both, if you both completely don't agree, whenever I say student is boredom and she says it's frustrated, then it's kind of, negative Kappa can possible. So negative Kappa means there's no absolute no relationship. Kappa equal to 0 means just by chance, like it's there's no intelligence or no agreement between both of us. Kappa equal to 1 is a perfect agreement. Kappa equal to beyond 1 to 4, we need to see. And we actually mentioned somewhere in weekly how to infer these kappa values. It depends on the domain we mentioned. For example, we said that in education domain, if your kappa value is point 0 to um, point 2 to point 4, it is fair. And more than point 5 is good for prediction problems. So this is good for ML classifiers. If I use the kappa is point 4, my classifier is doing good. I can go and say my classifier predicting students' frustration or boredom from the log data is decently doing good. So point 4 in education is good, but in other domain, they won't accept this point for as a good value. But I think I also made somewhere statement is kappa equal point 0.8 is good for interrelativity. So we are calculating the kappa, Kogan's kappa, for different purposes. One purpose is to measure the performance of my classifier. So I can say point 4 is good. But when we are measuring the interrelativity, like as I mentioned, if there's a student interacting in the classroom and we have two observers observing the student's affective states like confusion or boredom, when we are doing it, we should agree that we both are predicting the student's facial expressions correctly. If you don't have agreement, I'm kind of biased towards my prediction. My research is not actually correct. My results output, my inferences, everything biased towards um, my ability to read the facial expression and predict it. So before doing that kind of analysis, we need to establish the interrelated reliability. To do that, what do you use the Kappa score? That is the idea we are talking about here. So if it is for interrelated reliability, the Kappa should be above zero point 0.8 for the research articles. You could read any of the research articles which includes qualitative analysis or even quantitative analysis, where their human data is rated as the label data. They would mention that the interrelated reliability is zero point 0.8. Or you could read any paper which is systematic literature reviews, SLRs. They would say that the authors had the exclusion criteria and we both agreed on that. It's more than zero point 0.8. That makes sense. So when you're checking the interrelativity, the kappa 0.8 is good. In ML models to predict, in education domain to predict something, say the cognitive engagement, the affective states or metacognition, 0.4 or more than 0.4 is good, not a bad value. Okay, I hope this is clear because we gave two different values for kappa. I think that might be a confusion. That's why we want to talk about this in this class. And yeah, this also we'll discuss in next week when you will go to um, the descriptive analytics visualization comes in next week. So we talk about multiple charts, pie chart, and so there are multiple charts. I think go ahead and read about these charts, check the internet. What is the advantage and disadvantage of these charts? The one thing is that we are not clearly mentioned what is the advantage of these two charts. This is the bar chart. This is stacked bar chart. In the bar chart, like class, there are 4 grades, class 9, 10, 11, and 12. There are male and female, boys and girls. Boys, the absentee rate or the absentee rate, and girls absent rate is kind of plotted. This is used to compare the values of different categories, like boys and girls we compare. It's very simple and easy to compare. I can say that on all those grades, boys attendance is very more compared to girls, which means girls come to class more regularly compared to the boys. And I can say class 12 is worst compared to the class 9, the grade 9. In fact, the girls also there are a lot of absentees in class 12 compared to class 9 or class 10 or class 11. So there's incremental trend. There is a relationship is there. It is easy to compare. So visually, it's comparable easy. But if I have too many categories, so I have categories like 0 to 10 or the like different kind of countries, different kind of type of negotiation, something like that. A lot of things coming in categories. Plotting this bar chart and comparing is not good. So try to avoid it. So that's where you cannot use this bar chart. Also, if I have like 5 categories, it will take a lot of space. For example, if 5 bars for each grade, it will be like too much space. It's a spacey. That's the only issue in the bar chart. In a stack bar chart, what really happens, it reduces space. We can put the, two categories on top of it. And it is good to, it actually tells total contribution, mean like how much the girls and boys are contributing that absentee rate, and is efficiency in space. And it can also identify the trend, like this blue is kind of increasing, also the green is increasing, so trend can be identified. Again, the lot of categories is the issue. Again, here we cannot compare either boys is more or girls more. I need to look at the 41 and subtract it from the 20. What is this values? Not easy to compare. It's not simple, but this is very simple. Oh, that's the difference. I hope this is clear. This will be discussing in as class. I think this will be helpful when you are doing the week 4. So now I'll go to the couple of questions which which we got it from the discussion forum, that is in the Google, the discussion forum of the course. Please post your questions there, or no, we can answer them. So it says that why is dashboard in learning analytics? In learning analytics, if you look at the definition of learning analytics, is to design, design this metric, measure the data, and analyze the data. And so that we can understand the students' learning processes, we can provide a scaffold, or we can provide some kind of feedback so the students can learn better. To provide this feedback, it can be multiple formats. Feedback can be text, feedback can be adapting the content, feedback can be the visual representation of their performance compared to it. And also these data can come to the teacher in a bigger dashboard, like with 60 students are working on, we can understand these students' learning processes, or where there's lack, which courses, or which particular content we need to repeat again, those kind of things. So dashboard is a very good way to keep all those things together. Dashboard is basically, we saw the descriptive analytics, which is kind of creating, interactive dashboards. And I would suggest to do that. I would suggest to do those dashboard kind of analytics. Use some of the off-the-shelf softwares like Tableau, or some other softwares which you can Power BI. You can just feed the data with multiple labels, multiple features. Then you can create interactive relationship between these features, and you can make a dashboard so that somebody can interact. Domains of AI. What is domains of AI basically?
They wanted to know about whether the deep learning comes in the AI or machine learning comes in the AI.
I think we would have mentioned one. I think we'll be talking about in a 5th week or something when you talk about the predictive analytics, right? AI is a big circle. Within the circle, ML, machine learning comes. Within the ML, deep learning comes. If you look at it, so deep learning is a subset of ML. ML is a subset of AI. That's the way people look at it. Everything we saw, generative AI, all this comes under AI type of scales. But if you are really interested in understanding this, go and find out either in the web. There's the pictures representing this kind of relationship. So, but in general, as of now, it's AI. Within AI, there are multiple things. Machine learning is the one way. So we want to create artificial intelligence. The only way is that you can teach the machines, that is machine learning. Within machine learning, there are many methods. One method is naive-based, or SVM, clustering, supervised, unsupervised. One type of method is artificial neural network. And artificial networks, we have perceptrons, multi-layer perceptrons. Then extension is what deep learning it comes in. So all this thing comes under machine learning. The machine learning is to create artificial intelligence. So that's our understanding. That's how we look at it.
Yeah, it's a good thing that in the discussion forum, one of the participant has mentioned what is the AI domain, and he has put that diagram.
Nice.
So the one circle is AI, and then deep learning, machine learning.
So I think when somebody asks questions, please proactively go and answer it if you're confident about, if you know the domain. I think the more learning happens in the peer learning compared to looking at the video. So the learning happens when you engage and interact. Thanks for that, answering the questions. And there are a couple of questions we got it from the Google form. The one is, I mentioned somewhere in the course, there are mini projects in it. It's not a mini project per se, because I can do mini project, but we don't have a mechanism to go and validate it when like 4,000, 5,000 students doing the course. And so when we say mini project, what we mean is that whenever we introduce a tool, we'll be introducing at least 4 to 5 tools in this whole course, right? We will be talking about
Orange,
first Orange will come back. Becca would come very early. Orange, we would talk about process mining software. We would talk about it is for ISAT is up.
It is there.
I think we talk about ISAT, Orange, Becca. I think we're going to talk. I also introduce a bit of NLP. When I introduce a tool, what we are talking about is that we initially thought we'll do assignments based on the data and you work on it. But instead, we talk about the tool. I would ask you to go ahead and download the data from the um, Kaggle or any other data source available. Try that in the software. For the process mining, we would be looking at we'll be looking at we'll be looking at the data in sequential order. We may not get it, but you need to create the data like that. We'll be explaining sequence action 1, action 2, action 3. Then we try to find a pattern. So use those kind of data. You create the data, then you try to use SPM tools, the process mining tools. That's the idea. And question in the final exam. So what we are doing this time is most of the questions, at least 50% of the questions will come from assignments. So I request you to do the assignments properly and read the assignment questions, do the variation of questions, like numbers change, try different variations. 50 marks will be from assignments, and at least 20% marks will be from the slides kind of thing, which we're discussing slides. Basic question like this MNR is, should I ignore MCNR, MNR, something like that questions. And that's the idea. Some questions will be like open-ended to test we're able to apply this knowledge on the different scenarios. Why Orange? Orange is the ML tool. It is not just visualization. We'll be using Orange for prediction ML model when we come to the week 5 or week 6. So Orange is one of the good ML tool which can be used to predict. So if you don't know how to use Orange, I think all these tools we talk is well established. So I would just suggest you go to YouTube, type Orange tutorial. A lot of people learning. Orange also give their own tutorial how to do each and every step. So that's good. So the whole idea in this course, the course is called Learning Analytics Tools. Instead of only learning analytics, we introduce a tool so that you apply and do it. If you're only struggling in the tools, it's all established tools. Go to YouTube and find the related videos, because we were not able to explain everything in Orange. That would take complete 12 weeks course, right? That's the idea. So I would suggest go to Rapid Miners, get Orange, get Tableau, Power BI. These tools are really good tools for visualization or ML models. And can you suggest some tools for business analytics? So for the business analytics in the corporate companies, they are using tools like Power BI. Most of the companies, or the Tableau. Yeah. So, but it depends on the task. So the only good way to identify the which tools are good for business analytics, I would suggest go to search today, because the tools are evolving really quickly and rapidly. So I would ask you to search in Google and find out what are the top 10 tools used for industry for business analytics. Then you would be able to get the idea of which tool is the useful. So the currently used tool is mostly Power BI and Tableau. Power BI from Microsoft and or Data Studio from Google. So these are tools currently used. That's all. Okay.
Yeah, one question has raised by Akshay. Will case-based real-life example questions can come in a final exam?
What we do in final exam, I'll give you an example. We would say that here as the 10 numbers of attendance and the performance of class 8 students. We'll give that kind of table of 10 students, because we can't give too much data. And what we would expect you to ask questions based on, can you compute a correlation? Can you compute, looking at this data, what do you think is the correlation look like? Looking at this data, can you compute the Kappa value? Those kind of questions will be asked. That is a maximum case base we can think of. In the given limit of the NP, like the exam time, we can't really give a lot of data and analyze it. Or the case-based data will be like, if you are to conduct a study in a class 8 students and you are collecting data on the performance, the facial expression or something, what are the concerns you need? Which is most important concerns you need? Since it is class 8 students, you need to think about the age. The age will be 13, or 14. If it is less than 18, you know that by second week, if their students or people are less than 18, you need a parent consent also. If you miss the parent consent in the answer, then it's missing. So that's what we're looking at. So when you say case-based, we will try to think about a scenario in the classroom or collection. Then we'll ask questions based on it. But in the question, then the question is basically um, ethics or performing the correlation, performing this Kappa values, all those things, position recall. So please, check those values. That will be in the assignment.
Yeah, or it is based on the analysis, whether it is a descriptive analysis or prediction analysis. So in a questions, as a case-based real life, we are going to provide you a scenario, as sir said, the classroom scenario. And through that classroom scenario, you need to analyze the descriptive analysis or the prediction analysis. So that kind of questions will be there.
Yeah. That's the maximum case-based analysis. I think I hope this answers clear. If any other questions, you can post the questions in the YouTube chat.
So still we have a time. If you have any questions, please raise your questions.
We'll wait for 5 more minutes. This video will be added in the NPTEL, NPTEL the course web page of this live interaction. So we post tomorrow that this live interaction also contains also reading materials. So I would suggest you check the live video.
And please try to attend the Tuesday's live sessions, which is based on the assignments. So whatever the queries related to the assignment, you can clear there.
It's based on last year's assignment, not this year's assignment. But kind of similar questions you would see, but that would help you to solve the assignments problems in this year. We'll stop sharing the screen. So, yeah. Okay, I think that's a question. Thank you. Thank you for joining this live interaction session. And if you have any questions, please start posting them in the discussion forums. If you see somebody ask the questions, you can answer the question. Please go ahead and answer those questions. And we'll have one more live interaction in the next month after around week 7 or week 8. And one more just before the exams. If you have any questions by that time, we'll let you know. Yeah.
So one more question has come. Can you explain the post-processing a bit more?
Okay. So pre-processing is very important. We talked about pre-processing because the data might have missed it, so that we have to consider when we do the ML models, so that ML can predict well. Post-processing is basically to when you're taking inference from the data, and the data is valid, the inferences you make is valid and it's reliable. That's where the post-processing comes. In this course, we avoided it because it was not part of the inference making is not part of this course. Okay, that is we left to the researchers and the participants. That's why we didn't do the post-processing. To make this post-processing, when you say valid or reliable, the best way is the statistical measures. We can do the statistical measures to make sure that the claims we make as the proper backed up by data. And also we could say that we can do post-hoc analysis to prove that the inference we make as backed by data. That is the one way of post-processing we can do. In data minute level, there's no post-processing needed. The other one is post-processing is that suppose you collect the data from the multiple channels, right? Eye trackers and facial expressions kind of data. While processing, you will use the data, with a multiple different feature, different dimension, and combine it. When you explaining it, you cannot explain it saying that this particular face and something. You have to again recreate the interaction we give it based on the original data. Say that if the student is bored in this particular scenario with this kind of patterns, we could able to tell that the student is not able to solve the problem, something like that. That kind of link kind of post processing. But that is depends on the type of research question you're asking, type of hypothesis you want to prove. So that's why we didn't want to talk as post processing in this course.
Descriptive analysis doesn't come in the post processing because that we are using in the dashboard also to
Yes.
visualize the data. So
I think it just describes the data. Post processing usually means proving the hypothesis or trying to reconstruct the data to explain the common concept. But we don't really do that. That's in the course.
hope we answered your question, Akshay.
Yeah.
So if any question is there, please raise your question. Otherwise, we can conclude.
Yeah, I think we can conclude.
Yeah.
Okay, thank you. Thank you for joining this live interactions. And yeah, we'll meet, as I mentioned, we'll meet a couple of more times. If you have any questions, please keep sending questions in discussion forum, and I will see you next month. Thank you. The course is fully focused. Okay, I'm just one more question coming in. I think I know there's a delay maybe. The course is fully focusing on CS only or not? Actually, when we created a course, we never thought about a computer science only. So this is for anybody who are interested in learning about data, learning analytics. That's why course is kept very basic. The maximum maths we use is correlation, Kappa scores. That's the maximum math we will use it. We'll teach about come up with clustering mechanisms, but we'll never go into the math begin any of these machine learning models like linear regression or clustering. So we kept it for generic, not for the CS only. Because CS students would definitely know what we are talking in this course already. CS student for them is just application of the new domain. This course is for non-CS students, in fact. But I think still it feels like a CS because we talk about a lot of CS concepts. But the maximum math we talk about is Kappa correlation. That's all. I think that will also be explained. Maybe you have to look at the box plot. You have to look at this descriptive statistic. That's all maximum we'll talk about. So it's not for CS only. Okay, I think okay. I think we'll conclude here, and thanks for participating. So should I end? Oh, it's still going.